Welcome to Chem 121 Lab Online. It's going to be an adventure. I also didn't know that there were going to be quite as many boxes in the lab as there are, so you know what? We just keep adding more fun to the fun that we're having. I hope that the very first thing you notice when you start watching this video is what's on my face, which is goggles. You don't have to think about lab safety very much this semester, but I want you to do it anyway, because someday you'll be back in a real chemistry lab and I don't want you to be hurt. So I want you to see me using safety precautions, and I want you to be thinking about what safety precautions you would use if you were in the lab with me. The plan here is going to be that you're going to watch me do these labs. As you watch me do the lab, you should be writing down the procedure that you see me do. In particular, please make sure that you're making notes of any ways the procedure I do differs from what you find in your lab manual. You should have a lab manual that looks something like this that you got from the bookstore that you should be following along with as you're watching me do the lab. One thing that I can't say too many times, do not copy verbatim the words in the lab manual. That's plagiarism, first of all. It's also really unhelpful for your learning. All right, so the two things I want you to think about are making good observations and taking good notes, and safety as we go through the lab. All right, the first lab that we're going to do is we're going to determine the density of these metal cylinders. We have 5 cylinders of different sizes made of 2 different metals, and we're going to use different techniques for each set of cylinders to determine the density. To figure out the density, we basically need 2 pieces of information. We need to know the mass of each cylinder, and we need to know the volume of each cylinder. For the zinc cylinders, we'll use the top loading balance to find the mass. These balances are very convenient. They give us 2 digits to the right of the decimal, which is not bad in terms of precision. They're relatively inexpensive. They're pretty hardy. It's hard to mess them up. So they're sort of the workhorse of the science lab. So I'm going to start with zinc cylinder number 1, place it on the balance, and write down its mass, 35.75 grams. Zinc cylinder number 2, 48.80 grams. Zinc cylinder number 3, 72.34 grams. Zinc cylinder number 4, 92.74 grams. And zinc cylinder number 5, 109.90 grams. I'm always going to write down, wait, is that 91? Yeah, it looks like that's 91. I'm always going to write down, now it's going to change. You know what? We're going to call it 91. I'm always going to write down every digit that the balance gives me on my piece of paper. Hopefully you weren't surprised to see that as the cylinders got larger, their masses got bigger. That should be consistent with what you know about, things. The aluminum cylinders are less massive than the zinc cylinders are. Spoiler alert, that's going to matter later. So we're going to use the more precise balance for this. There's no special reason to use this other than I want you to see both of these balances at work. So these balances, as you'll see, read to 4 digits to the right of the decimal place. You also see that they live inside these cages. That's because if I open the door and wave my hand, you can see that the number changes. That's how sensitive these balances are. I didn't even blow in there. I just waved my hand and the number changed. So when we use this balance, we want to make sure that all of the doors are closed. And we need to wait a second for air currents to stop, and then we'll zero the balance. Now we'll place our first aluminum cylinder in, close the door, 8.6039 grams. Cylinder 2. 12.8828 grams. I'm always going to write down every single digit this balance gives me. The way I always describe it is these significant figures are expensive. A lot of your technology fee money went into buying these expensive digits to the right of the decimal place. So why on earth wouldn't you write them all down? 17.5747 grams for cylinder 3. Cylinder 4, almost forgot to close the door, 21.9020 grams, wait, all right, 9019, I find it hard to believe, really? You know what, fine, we're going to call it 9020. And finally, aluminum cylinder number 5, 26 0.4316 gram. We will use these balances in labs where we're trying to find an answer precisely, but also when we're using fairly small masses. The maximum mass that this balance can hold is a lot smaller than the ones out there in the lab. To get the volume of the aluminum cylinders, we're going to use a little geometry. You might remember the equation for the volume of a cylinder, and if not, you can look it up easily and it's in your lab manual. To find the volume of the cylinder, we need the diameter of the cylinder and we need the length of the cylinder. All of these cylinders have the same diameter. They were all cut from the same piece of metal tubing or piping or something originally. So I really only have to get the diameter of one of them. To get the diameter, I'm going to use calipers. If we were doing this class for real, I would teach you to use calipers. It's a handy skill to have, but for the sake of this lab, I'm just going to tell you what the numbers are. So I close the jaws of the calipers down on my cylinder. I'm going to record on the centimeter side. So I'm looking up here, and I'm not going to tell you how to do this. I'm just going to do it for you. My diameter is 12.65 millimeters. All right, and now for the lengths. The length of cylinder 1, 25.45 millimeters. Cylinder 2, 37.90. Cylinder 3, 51.70. Cylinder 4, 64.55. Cylinder 5, 77.75. We'll use a different technique to find the volume of the zinc cylinders here in just a minute. To find the volume of the aluminum cylinders, we use geometry. We measure the lengths and we measure the diameters, and we'll do some math to figure out what the volume of the cylinders are. But to find the volume of the zinc cylinders, we're going to use a different technique. We're going to use water displacement. Water displacement is a powerful technique that can be used on things that don't have an equation to tell you their volume, so things that are irregularly shaped. In actual fact, these zinc cylinders are pretty regular. We really don't have to use this, but the goal of this is to show you different laboratory techniques as opposed to actually, the ones that we most need. So what we're going to do is we're going to pour some water into the graduated cylinder. I have my water waiting for me here just so we can do this a little bit more efficiently. I'm going to record the volume of water in my graduated cylinder. I'm recording at the meniscus, which is the bottom surface of the water. You'll see that the water is slightly curved. We'll talk about what intermolecular forces make that happen. Now, depending on how well you can see that video, you might be thinking to yourself, that's 19 milliliters. But that's not using the measuring device correctly. We always want to estimate between the lines. So we don't just want to call that 19. We want to estimate to one more digit. Everybody agrees that that's about 19. To be sure that we're measuring correctly, we have to go a step further than that. And this is where the uncertainty in our measurement comes in, because I think that looks like it's a little bit below the line. I'm going to call that measurement 18.9 milliliters. You might have felt like it was exactly on the line, in which case you would call it 19.0 milliliters if you were really sure. All right, the most important lab safety rules are the ones that keep us safe. But the other important lab safety rules are the ones that protect the equipment. The equipment is not as important as the people, but it is still important. One of the things that we can do easily in this lab is break the glass graduated cylinders if we just drop these metal cylinders inside. So what we're going to do instead is we're going to tilt the glass cylinder on its side, we're going to put the metal cylinder on its edge, and let it slide down into the water. Also, if we drop it from up here, there's a decent chance that some of the water that was in the cylinder will splash up and out and change our final volume. So I'm going to bring this up to my eye. If you're looking at this, you're thinking it's about 24, but we have to estimate one digit. I'm going to call that 24.1. All right, and now we're going to repeat the procedure again. We're going to pour in some water. And we're going to come down here. We're going to look at that volume, which looks to me to be a little below 19. I'm weirdly consistent with this today, but I think that's about 18.7 is what I'm going to call that. And now in goes zinc cylinder number 2. Again, we're going to lean on the side, slide it down in. $25.6. All right, and we keep going. I need to make sure I have enough water in here to cover the cylinder, but not so much that when the cylinder is in there, I go over my 50 milliliters. This time I have, really and truly, I'm hitting almost exactly right around between 18 and 19 each time, but I think that's 17.9. All right, cylinder number 3. $27.1. Oh, I have a little more this time. I'm going to say that looks to me like 19.7. Here comes cylinder number 4. Cylinder number 4 is at, I actually think that is 33.0. A 0.0 is going to happen once in a while. And again, your eye may see that slightly differently, and that's okay. That's why we'll say that there is uncertainty in that last digit. All right. $23.9. I'm going to be extra careful here. And we have 39.6 milliliters. And now we have everything we need to get the volume of all 5 zinc cylinders. Now that you've watched the video for the density lab, you should have all the data that you need to do the calculations. We're going to calculate the density of each of the metal cylinders, and then you're going to create a graph to find the density of the cylinders. With the data that you have, you should be able to do the calculations for volume and for density for the first one, and then you're going to use that data to create a graph. Some of you probably already are pretty confident taking a collection of data points and putting them into some sort of program to generate a graph. Those of you who aren't, this is a good skill that we're going to learn. So the two programs that are probably used the most widely for this are Microsoft Excel and Google Sheets. You should choose which of those platforms you're more comfortable with. And because each of them is different, and I think different versions may be different, I'm going to recommend that you start by Googling how to do it in your specific program. And then if you run into snags, come and let me know, and I'll see if I can help you. So if you have questions about that or anything else, just send me an email. As you may recall, the lab handout will be due 48 hours after the lab is posted, and I'm going to plan on posting the lab videos at 10 o'clock in the morning every morning. So, best of luck. Let me know if you have any trouble.